Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 1. In today's lesson, we will talk about projectile motion, we will talk about momentum, we will talk about forces, and we will also talk about energy. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 6 says, a student determined the acceleration of free fall. She measured the time t for a ball bearing to fall from rest through a distance s. She repeated this for a range of values of s. Which row of the table shows the graph that would give a gradient equivalent to g? So for this question, simply she dropped a ball bearing from certain height, and the height is given to us. In this case, this height is s. So simply we can draw here, this height is s. For this one, we need to determine value of g, and this ball bearing started from rest, u is equal to 0. In this case, acceleration is constant, so simply we can say s will be equal to ut plus 1/2 at square. As initial velocity is equal to 0, so simply we can say this is equal to 0. So here we will have 1/2 at square. We can also write down this one 2s. This will be equal to at square. Now if we sketch a graph between 2s and between t square, gradient of the graph will be equal to a. We can simply compare this one with straight line equation, y is equal to mx. So this quantity is s, this quantity is y, so the gradient in this case will be equal to a, and a in this case is equal to g. A is equal to g. So the answer for this question has to be b. So b is the right answer. Pretty straightforward question. If you have done this experiment, simply you can look at the given options and you can find the answer. Question 7 says, a car travels with a velocity of 3 meters per second. The car accelerates uniformly in a straight line for a distance of 15 meters. The final velocity of the car is 5 meters per second. Which of the following expressions gives the acceleration of the car in meters per second per second? For this question, it is given to us the car is moving in a straight line. So car is moving in a straight line. So we can also simply draw the car here. So this one is the car. Initial velocity of the car is given to us, that is 3 meters per second, and final velocity of the car we have, that is 5 meters per second. And the distance traveled by the car is given, so we can also write down the distance travel. Distance travel is 15 meters. So this is the distance traveled. We need to calculate value of acceleration. This is what we need to calculate. Acceleration is constant, so simply we can use 2as is equal to v square minus u square. We need to calculate value of a, so we can write down a will be equal to v square minus u square divided by 2s. Value of v is given, that is 5, and value of u is given, that is 3, divided by 2 times 15. Now if you look at given options, option D, so this is our right answer. So option D is the right answer. So this is how you can figure out. Question 8 says, an object accelerates from rest down a frictionless slope. The object moves a distance of 20 meters. The slope is at an angle of 23 degrees to the horizontal as shown in the figure. Which of the following gives the final speed of the object in meters per second? Main question is simply asking us what will be the speed of the object at this point. So we can say this speed is v. So this is what we need to calculate. What is value of v? In order to answer this question, we can simply draw first of all the force acting on this object. So this is the gravity. Gravity is acting vertically down. And we can also resolve this gravity into components. So this is one component and this is the other component of this. Otherwise, the better way to draw this one is the second component we can draw here. So this is an other component of weight, component of gravity. So these are two components. This angle will be 23 degrees, and this component is perpendicular to the plane, and this is along the plane. If weight of object is mg, so this component will be mg sine of 23 degrees. So in this case, the net force acting on this object, we can say F net, that will be equal to mg sine of 23 degrees. And this is also the reason, very important point. If you understand, it's wonderful. If you don't understand, let's try to understand now. So imagine that if I place this marker on this box like this marker just stay here. But if I increase the angle with horizontal, this marker will go down. Why this marker go down? This marker will go down because there is a force acting on the object down the plane, and that is component of gravity, and so that's the reason it will go down. So from here we can find out value of a. So we can say ma, this will be equal to mg sine of 23 degrees. We can cancel m with m, so a in this case, this is equal to g sine of 23 degrees. This object started from rest, so u is equal to 0 meters per second, and acceleration is constant, so simply we can write down v square minus u square. This will be equal to 2as, and in this case we are taking down the plane. This direction we are taking as positive, so we can write down v square will be equal to u square plus 2as. U is equal to 0, so this one is equal to 0. So simply we can write down 2 times a is equal to g sine of 23 degrees, and s is equal to 20 meters. So the value of v, simply you have to take square root on both sides. So this is the final answer, and if you look at the given options, we have 2, so we can write down also in a better way. We can say this is 2 times 9.81 times 20 times we have sine of 23 degrees. So this is a better way of writing. So this is our final answer, and if you look at given options, C is the right answer. So this is the answer. So this is how we can answer. There is an other way to answer this question. We can also use conservation of energy. Let me explain you with the help of conservation of energy. Conservation of mechanical energy in this case, because there is no friction, so we will say conservation of mechanical energy. At this point, object has certain gravitational potential energy, and we can take our reference line. So this is our reference line, means the GPE at this point, at this level, GPE is equal to 0. We can say GPE here is equal to 0. So at this point, object will have kinetic energy, and here kinetic energy of the object is equal to 0. Now from here we can write down change in GPE, that has to be equal to the change in kinetic energy, and change in GPE we can write down that has to be equal to mg delta h, and that has to be equal to 1/2 mv square, because initial speed is equal to 0. We can further simplify this. We can cancel m with m, means it is not depending on mass. So this is very important point. It doesn't matter I have a big box, I have a small box, they will reach this point with the same speed if we release them from the same height. A beautiful point you need to understand. So from here we can say v square, this will be equal to 2g delta h, root of this one. So we have here 2 and we have g, that is equal to 9.81. so how we can find the height? So let me little bit clean this one. How we can find the height means this height, how we can find this? We have 20, we have angle, so this has to be 20 sine of angle, sine of 23 degrees. So we can write on here, so this is 20 times sine of 23 degrees, root of this. So this is the value of v. So answer is C for this question. A beautiful question. Try to do this one using these two different methods. This will help you to improve your understanding of forces and kinematics. Question 9 says a ball bearing falls at terminal velocity through a liquid. The temperature of the liquid increases and ball bearing falls with a greater terminal velocity. Which row of the table is correct as the temperature of the liquid increases? For the first case, it is given to us ball bearing is falling at terminal velocity, and terminal velocity means the velocity is constant. So here is the drag force. So in this case, we can say this is the mg and this one is the drag force. Object is falling at terminal velocity, it means these two forces are equal. So Vt means the terminal velocity, this is constant, so resultant force is equal to 0. Then temperature of the liquid increases. As temperature of the liquid increases, viscosity of the liquid will go down and terminal velocity of ball bearing this increases, but it is again moving at constant velocity. So we can redraw. So here is mg and here we have drag force. So this is the drag force Ft. It is falling again at constant velocity. It also means that these two forces again they are equal. So Fd is equal to mg, and in the first case Fd drag force, this is also equal to mg. So it simply means that viscous drag remains constant and viscosity of the liquid decreases. So the answer for this question has to be B. Drag force remains constant, viscosity decreases. So the answer for this question is B. So B is the right answer. So this is how we can answer this question. When body is falling at constant velocity, terminal velocity, resultant force has to be equal to 0. Question 10 says two identical springs are arranged in series. A force of 45 newtons is applied to the springs as shown in the figure. The springs extend a total distance of 15 millimeters. Which of the following expressions gives the stiffness of each spring in newtons per millimeter? So for this one we need to understand when the springs they are connected in series, force on each spring is the same. It means 45 Newton force is acting on this spring and 45 Newton force is acting on this spring as well, because these springs are massless. So springs are massless, so we can say springs are massless. So force on each spring is the same. So force on each spring is the same. On each spring is the same. So this is the main concept you need to understand, is the same. If this concept is clear to you, now we can simply write down total extension we have, that one has to be equal to x1 plus x2, and this is equal to x, means the total extension. Total extension is given to us, that is equal to 15 millimeters. So this is 15 millimeters, and x1 we can simply find out. This has to be equal to f divided by k plus this has to be f divided by k. Now if we simplify, we can say this is 2 times f divided by k, and this is equal to 15. So from here we can say k has to be equal to 2f divided by 15. So we have value of force that is equal to 45 newtons divided by 15 millimeters. So this is in Newton. So this is our final answer. If you look at given options, so option D is correct. 2 times 45 divided by 15. So the answer is D. So the beautiful question, when springs are connected in series, each spring experience the same force because we assume springs are massless. And if that is clear to you, then simply you can answer this type of problems. So this is our main concept for this question. Question 11 says a rock falls from rest through a small distance s to the surface of Mars. The rock hits Mars with velocity vm. Another rock falls from rest through distance s to the surface of Earth and hits Earth with velocity ve. Calculate the ratio between vm and ve. Acceleration due to gravity on Mars is equal to 0.38 g. So we can simply write on, first of all, acceleration on the surface of Mars is equal to 0.38 g. So we have two situations. So we can consider the first case where we have the Mars. So here is for the Mars, and it is given to us the distance from the surface of the Mars. This is s. So this is, let's say, the surface of the Mars, and it is started from rest, so u is equal to 0. And the second case we have for our planet on Earth. So we can say this is for Earth, and it started also from rest. So we can say u here equal to 0 as well, and the distance fallen is s. So we need to find out simply what is the velocity when the ball just hit the surface. When the ball just hit this surface, what is that velocity? That v we have to find out, and that is ve. And same for the Mars, when it hit the surface of the Mars, what is that velocity? That is vm. So we can say this is v sub m. We need to find the ratio between vm and ve. So first of all, we can find out vm. Vm, in this case, acceleration is constant, so simply we can use v square minus u square. This has to be equal to 2as. So we can say v square, this has to be equal to u square plus 2as, and in this case we are taking downwards as positive. U is equal to 0, so this is equal to 0. So we can say v, simply this will be equal to 2 times value of gm, and gm is equal to 0.38 times g times s. So this is vm. So we can say this is value of vm. So we can say this is vm. And same we can do for ve. So ve has to be equal to 2as root of this. So we can say this is 2 times g times s. So this is value of ve. Now we need to find the ratio between these two. So the ratio between these two. So vm divided by ve. We have value of vm, that is 2 times 0.38 times g times s divided by, we have 2 times g times s and the root of these two here. Now from here simply we can cancel this g with this g, this 2 with this 2, and this s with this s. So if we take square root of 0.38, we will get that will be equal to 0.62. So this is the ratio between vm and ve. So it means vm is slower, and this is equal to about 0.62 of ve. For the answer of this question, this is the answer, but you can compare how fast is ve. So vm is equal to 0.62 times ve. So the speed on the surface of the Earth is faster because value of acceleration is greater, and this value is lower because acceleration on the surface of Mars is smaller. So this is our final answer. Question 12 says a man dives from a platform into a swimming pool. The platform is 12 meters above water surface as shown in the figure. So this is 12 meters above the surface of water. Question A says state how the graph shows that the man's initial vertical velocity is 0. So we have here displacement against time graph, and this is vertical displacement against time graph. Vertical displacement against time graph. And we need to understand gradient of dt graph means the gradient of displacement against time graph represents velocity. So simply we need to draw the tangent line and we need to find the gradient. So if we draw the tangent line here, gradient of this tangent line is equal to 0. So simply we can say as initial gradient is equal to 0, it means that initial vertical velocity is equal to 0. So simply we can say as initial gradient is equal to 0, so the initial vertical velocity is also equal to 0. For the second part, we need to determine the vertical velocity of the man as he enters the water. So the person will enter water at this point, means the displacement will be equal to 0. So at this point we need to find out the velocity. What is value of v at this point? Then this person started from rest, so we have the initial velocity that is equal to 0, and we have value of displacement, and it is in free fall, so the acceleration will be equal to g, means a will be equal to g. Now simply we can use kinematic equation, so we can write down v square minus u square. This will be equal to 2as. For this question we need to calculate value of v square. We can say this will be equal to u square plus 2as, and u is equal to 0, so we can say this is equal to 0. So simply we left with v, and v will be equal to 2as, and a in this case is equal to g, so we can say this is 2gs root of this one. So we have 2 and g is equal to 9.81, and value of s that is equal to 12. Now simply we can solve this one, and we will get our answer is 15.3 meters per second. So this is the vertical velocity when the person is at this point, means just enters the water. So the value of v at this point is equal to 15.3 meters per second. So this is one way you can answer this problem. And other way to answer this question is we can also draw the tangent line at this point, and we can find the gradient of that tangent line. So in this case we can draw here tangent line, and we can find the gradient of tangent line, and that also will be equal to about 15 meters per second. So the answer for this question is 15.3 meters per second. So this is our final answer. Part B says before entering the water the man has a constant vertical acceleration. After entering the water the man has a constant vertical deceleration. Draw the velocity time graph for the man on the axis below. So if you look at displacement time graph, we have already said that initial velocity is equal to 0, and at time 1.5 seconds we have found velocity of v that was equal to 15.3 meters per second. Now if you look at this point, gradient is 0, it means the final velocity is also equal to 0. We can also understand this question a little bit in a different way. First of all, we can imagine at this point initial velocity of the person is 0, and this person start falling downwards, and when this person hit the water, we can say at this point the velocity of the person, this is equal to 15.3 meters per second, and acceleration is always downwards, so a is equal to g. And finally, when person is somewhere in the water, its velocity becomes 0. So at this point v2 is equal to 0. But when the person is inside water, acceleration is upward, so person will decelerate. So this is direction of acceleration when the person is inside water. This part is representing inside water. So direction of acceleration is in opposite directions. By convention, we take up is positive. So if we take up is positive, it means the velocity will be negative, so v will be negative in this region, and acceleration also will be negative. So we will say a is equal to g, but this has to be negative. So acceleration is negative, but acceleration here, this one will be positive. So if we have understanding of this point, now we can sketch the graph. So it started from rest, and at time 1.5 seconds, 1.5, so velocity is about 15.3 meters per second, and then at time here, velocity again become 0. Now simply we need to connect this one. We can draw the straight line because acceleration is constant, so we can draw a straight line here, and again acceleration is constant, so we can draw the straight line here. So this is how you can sketch. You can also see from here acceleration has different direction. Here we can see this gradient is negative, and here we can say the gradient is positive. So this gradient is negative and this gradient is positive. So this acceleration has positive direction and this one has negative direction. We can also see from here. So this is how you need to sketch this graph. Question 13 says a high-speed train accelerates from rest along a straight horizontal track. The final speed of the train is 76 meters per second. Show that the useful work done to accelerate the train is about 2 gigajoules, and mass of train is given to us. So first of all, we can simply sketch this. So in this case, we have a train, and this train started from rest. So the u for train is equal to 0 meters per second, and the final speed of the train, that is equal to 76 meters per second. So in this case, the useful work done on this train will be equal to the change in kinetic energy of the train. So we can say useful work done on train. So simply in this case, we can write down useful work done on train. This is equal to change in kinetic energy of the train, and change in kinetic energy of the train is equal to 1/2 mv square minus 1/2 mu square. So we have 1/2 mv square because this is equal to 0, because u is equal to 0. So this is also equal to 0. So we have 1/2 m is 7.2 times 10 to 5 kgs, and value of v is 76. So if we solve this one, we will get 2.08 times 10 to 9. So this is about 2 gigajoules. So this is about 2 gigajoules. So this is our final answer. So if you have written these steps, you will get 2 marks. 1 mark for writing the equation, and the second mark for calculations and correct answer. So we can say this one, actually the better way of writing this one is the better way, because this is 2.08 up to 2 dp. We can say this is 2.1 times 10 to 9 joules. So this is about 2 gigajoules. So this is better way of writing, because this is greater than 5. 5 are greater than 5, so this has to be 2.1. So this is our final answer. Part B says the train accelerates for 180 seconds. The train has an input power of 60 megawatts while accelerating. Determine the work done against a resistance as the train accelerates. So in this case, we need to understand total input energy. We can say energy input. We can write down in a better way. We can say input energy. In this case, input energy, this one has to be equal to useful work done. So we can say useful work done plus work done against a resistance. work done against a resistance. For this question, we need to calculate work done against a resistance. Work done against a resistance. So simply this one has to be equal to input energy minus useful work done. So we have minus useful work done. Input energy simply we can calculate because we have input power and the time is given to us. So the input energy will be 16 times 10 to 6 multiplied by time 180 and minus useful work done. We have already calculated 2.08 times 10 to 9. Now if we simplify this one, we will get our final answer will be equal to 8.0 times 10 to 8 joule. So this much work is done against a resistance, and this is our final answer. This question has 2 marks. The first mark you will get if you have calculated input energy correctly. You will get 1 mark, so this will be 1 mark. And the second mark you will get if you have got the right answer. So this is how you will get these 2 marks. That's all for today's lesson. I hope this video was helpful. If this video was helpful, please like and subscribe because your encouragement is very important. And if you need more help, you can also join Patreon. And Patreon you will find more resources, and also you can connect with me directly. See you in next video.